name is Yznaga.
And I'm Kevin Mendez.
And we're from Calculus 1, Section 19M, and this is our presentation. So problem 1 states, find the function f of x whose second derivative is f double prime of x equals 4x to the third plus 6x minus 1. Its first derivative, f prime of x, contains the points 1, 4, and function f of x contains the point 0, negative 3. So to begin finding the antiderivative of f double prime of x, you start with an integral sign, which indicates that you're finding an antiderivative, and then you rewrite the f double prime function, so 4x to the third minus 6 plus 6x minus 1. And then you're going to write dx to indicate that all the derivatives you're finding are with respect to x. So the dx is going to distribute amongst all the terms. So once you do that, you're going to separate each term with an integral sign. So your first is 4x to the third plus integral 6x minus, you add the dx after every term because you distributed the dx, minus 1 dx. So from here you're going to find the derivative of each individual term. So once you do that, the integral sign and the dx go away. So to find the derivative, you bring the 4 out because of the constant multiple rule. So 4x to the third is the antiderivative power rule. So you have x, n, which is 3, plus 1, x to the fourth over 4. And that's the derivative for the first one. Your 4's can cancel out, so you're left with x to the fourth plus 6, because of the constant multiple rule, x, n plus 1, so x is n is 1, plus 1 is 2, over 2. 6 and 2 divide to become 3, so you're left with 3x to the second. And finally, minus 1, which is a constant, so it's 1x. And then to simplify all of that, you're left with x to the fourth plus 3x to the second minus 1x. And this is the f prime function, since you went back on the f double prime with an antiderivative. After you write the function, after finding the antiderivative, you must always include plus c, because if you don't, this derivative could be infinitely many solutions. So by adding c, you're defining the function. So the original problem states that the first derivative, the one we found here, contains the points 1, 4. So with those points, you can find c. So the way to do that is to substitute the points into the variables given. So the y is 4, and then you substitute back into every x variable the 1 from the x. So it'll be 1 to the fourth plus 3, 1 to the second, minus 1 times 1 plus c. So this will give you 1 plus 3 minus 1, which results in 3. So you're left with 4 equals 3 plus c. Basic algebra, solve for c. Minus 3 minus 3. c is equal to 1. So then you rewrite the f prime of x function with c. So you have f prime of x equals x to the fourth plus 3x squared minus 1x plus 1. And then this is the first derivative of the function that was given. So to continue, to find the original function.
So now, to find the rest, like the question asks, to find out the function of the second derivative, we must use the first derivative of our rate as our function. So let me erase this real quick.
Do you want to leave this?
I'll leave that one. Okay. So basically, to find the function, you use the same process that Emma used. So you start. Okay, equals x fourth plus 3x squared minus 1x plus 1. Okay, so after this, like the previous process that Emma did, we are gonna, each term is gonna be separated with the antiderivative symbol. So let's do that. So it's gonna be x to the power of 4 plus.
And you would also apply dx to everything.
Apply dx. 3x cubed dx minus 1x dx plus 1x 1 dx. Sorry about that. And after that, we start applying the rules that we have learned previously. So right here we have x to the fourth, which applies the power rule, which states that x to the same power plus 1, so it's going to be x to the power of 5, and then to the same number 4 plus 1, which is 5 as well. Then we do the next power, so this is constant multiple, meaning that the constant multiple is moved out, which is 3, so plus 3, and then we apply the power rule to this one, which is x to the same power plus 1, which is x cubed, and then to the same number 3. Over here, we have constant multiple, meaning the constant multiple is moved out as well, 1, and then right here, we apply the power rule. Even though you don't see a power, if it doesn't have a power or a number on top, it's 1. So 1 plus 2 plus 1 is x squared, same number. And then over here in the last term, it's a constant. So the constant rule indicates that you put 1x plus c. After that, we simplify. So right here it stays as x fifth to the fifth. Right here, 3 cancel out. They don't cancel out, they just simplify. So you have plus x cubed minus, you can't simplify here, so the 1 is, since they're being multiplied, when you multiply 1 by something, it's the same number, so we're going to leave the 1 out, and x squared over 2 plus 1x plus c.
And to simplify even further, you can bring the 5 out and make it 1/5. So you would continue and have 1/5 x to the 5th plus x third to the 3rd minus 1/2. You bring the 2 out, x to the 2nd plus 1x plus c. And you can just take the 1 out since the x is only 1.
Okay, so after we have simplified the equation a little more, we then do the process that Emma did previously, which is applying the points to the function. So right here, -3 is y and 0 is x. So -3 goes in the beginning of the equation because of course f of x equals y. And then we apply 0, we substitute 0 to each of the x's. So it's going to be -3 equals 1 over 5, 0 to the 5th, plus 0 cubed minus 1 over 2, 0 squared plus 0 plus c. Now -3 equals 1 over 5, 0 to the 5th, plus 0 cubed minus 1 over 2, 0 squared plus 0 plus c. Now, basic algebra. So 0 to the power of 5 is 0, and then 1/5 over 0 times 0, I mean 1 over 5 times 0 is 0, so 3 comes down, 0, 0 cubed, 0 minus 0 squared is 0, and then you multiply 1/2 by 0, 0 plus 0 plus c. So here, all of these are zeros, of course, so -3 equals c.
So then you would rewrite the function, and now this is f of x. Since you went back on the f prime of x with the antiderivative rules. So you apply c to this function. So you have 1/5 x to the 5th plus x to the 3rd minus 1/2x squared plus x minus 3. And this is the function that we were originally looking for in the problem.